Hello, everybody. In today's episode, we're going to try to create an operating system within 1 hour. So, disclaimer, I have never looked into operating systems programming. I have no idea how operating systems work, but essentially the goal of this episode is just to try to get something running within an hour. If it doesn't work, it doesn't work. If it does work, then I'm going to party hard. But, okay, so we're probably going to need some C code, and I probably need to dig through a lot of documentation. And in the end, I have no idea what we're going to end up with. But I found in the past couple of episodes that whenever I try to do something where I have no idea how to achieve it, in the end somehow I'm more educated, even if the result is a failure. So let's delusionally just create an operating system. Okay, that's the goal. So I'm just going to naively do it. I don't care. Operating system. Let's create a project directory called operating system. And what's an operating system consisting of? A file, a C file, os.c. Does it need a main method? Does it need standard IO? Probably not. So I'm going to create a main method, and probably it's going to be that won't work, but I don't know. So starting the operating system here, I'm going to print that to the console. Actually, if we can print something to the console in the end, it would already be super nice. Okay, so now we have a file that prints something to the terminal. That's of course not an operating system. The difference between this piece of program right here and an actual operating system is that the operating system somehow has to boot from scratch. It has to run on bare metal rather than this program here, which is a user space program. Well, of course, I can compile it. Let's just do that. gcc os.c, and we have an executable now called a.out. If I execute it, it prints starting the operating system. But of course, that's just bullshit. So what we're going to do is open a browser and look for how to code an operating system. And there are a couple of choices, I think. I've seen some tutorials online in the past couple of months where someone tried to create an operating system based on Linux. So essentially they tried to create their own Linux distribution. That's not what I want. I actually want to create a real operating system myself. So let's see. There's a website here called OSDev Wiki. Let's see if we can get a bit more educated by reading through this. So, what is this even? This is osdev.org. It looks like a wiki page for operating systems. Contains some sections for bare bones code, kernel stuff, booting and setup, memory. Okay, so this sounds quite promising. And let's just try to read and skim through this and see if this is a useful resource. First of all, developing an operating system is probably one of the most challenging things you can do on a computer, next to killing the final boss in Doom or Nightmare difficulty level. Okay. Composing an operating system requires a lot of knowledge about several complex areas within computer science. Okay, I don't have that. You need to understand how hardware works and be able to read and write complex assembly language as well as higher level language. Wait, we need assembly language? Why do we need assembly language? I always thought that Linux was based on C. So is assembly language really necessary? Your mind has to be able to wrap itself around abstract theory and hold a myriad of thoughts. Feel discouraged yet? No. Don't fear, because all of these things are also the things that make OS programming fun and entertaining. There is nothing like the feeling of accomplishment when you finally, after hours of struggling, solve the problem, and after some time you are able to look back and see all of the things you've created from scratch. By the way, for those of you who don't know, you probably know Temple OS. If you don't, have a look at it. It's super funny. It's this guy here, Terry A. Davis, who wrote an operating system just by himself from scratch, and he created this ridiculously looking operating system called Temple OS, whose logo reminds of Jesus's cross, and it just looks super funny. But the big accomplishment here is that this has been created from absolute scratch by a single person, and this is incredible. So he really created a UI, an operating system with several programs, games, some music generation tools, and stuff like that. It's really funny to, but this guy was suffering under some mental disease, and the story didn't went too well in the end. Okay. So your OS is exactly that. It's yours. You have ultimate control, and the sky's the limit. By the way, do people really seriously create their own operating systems? I mean, I'm looking at it now from an educational perspective, but do people really try to create their own OS, and they mean it in the sense of they are going to use it themselves? That would be quite interesting to know. The hard truth. Hopefully, the basic fact that operating system development is a complicated and ongoing process does not discourage you. The truth is, operating system development is truly unparalleled, since it requires the utmost amount of patience and careful code design, and it returns very little to no instant gratification you get from the development of things like games and web-based scripting. So basically, all the stuff that I've been doing before. Well, no, I've not really been doing web-based scripting, but I've been doing some game-ish things, because a lot of the C projects done on this channel are simulations, stuff that was somehow, or that is somehow, visually appealing. You have been fairly warned. Okay, blah, blah, blah. I want to know how an operating system works now. So, required knowledge. If you think you can skip this, it's just for you. If you think you can skip this, it's just for you. This section has been moved to a separate page. Beginners in OS dev are strongly recommended to not skip this. Let's skim through this. So we need to know computer science. Okay, fine. I know how to write loops in C. Language and vocabulary. I know German and English. Language and vocabulary part 2. Okay. Something with programming. Assembly. Knowledge about the low-level language assembly. Read a book. Take a course at school. You will need it, even if you plan to write most of your operating system in a higher level language. I won't need assembly. Why would I need assembly? Programming experience. Learning about programming with an OS is a project is considered a bad idea. Not only should you know the language in which you will be developing inside out, you should also be familiar with version control. Oh, I know version control. I can deal with Git. But is it required? No. Okay, so fine. So basically this guy tells you you need to be able to program and compile stuff. That's it. I can do that. Organize your plans. And by the way, if you want to be able to do all of this stuff yourself, then have a look at the No Nonsense C programming course. It's linked in the description below the video. It's a course that teaches you C from scratch. Super valuable, and I have created it. So and you will see my insane skills come to fruit in this episode. So so much stuff being said here, but what do I need now? This is just generic programming how-to here. So let's go up a page and try to find something. I don't even know what to ask for. How to ask questions. GCC cross compiler. What order should I make things in? Maybe this tells me what I need to do first. For the starter, printing strings and integer numbers, both decimal and hex, on the screen is certainly a must. Okay. This is one of the most basic ways of debugging, and virtually all of us have gone through a kprint or kout in version 0.10. Kprint and kout is probably some kernel printing function. Outputting to a serial port will save you a lot of debugging time. You don't have to fear losing information due to scrolling. You will be able to test your OS from a console. Okay, I didn't even consider that there's not even a terminal in an OS, because I have to create the terminal myself. So I'm going to deal only with serial ports. So I'm going to deal with hardware directly. How the hell am I supposed to do that? How kernel, compiler, and C library work together using other languages than C. I don't need that, I need only C. Booting and setup. Boot sequence. When a computer is switched on or reset, it runs through a series of diagnostics called POST. Power on self-test. This sequence culminates in locating a bootable device, such as a floppy disk, CD-ROM, or hard disk in the order that the firmware is configured to. The legacy BIOS checks bootable devices for a boot signature, a so-called magic number. The boot signature is... Wait. Is there no guide that tells me what to start with? CPU in general. Bare bones. Example of OS organization. Diskless booting. How do I use a debugger? No. All of that is not helpful right now. It's way too generic and way too complete. This is trying to cover all the ins and outs of operating system development. I just want to know how to be able to start or create something simple that I can somehow boot. Oh, like this one. Make a simple operating system. This is some screen with something on it. Why is my screen flickering now? Now it's okay. Ever wanted to make an operating system? Yes. Ever wanted to know, or probably wanted to know how command line operating systems work? Everything's here. So we'll make a basic operating system in C#. Wait, on instructables.com, so this website here, this guy claims to have made an operating system in C#. How the hell is he supposed to do that if there's no C# runtime? Is he just going to full screen a terminal and then print some dummy text to the console maybe? Let's see. Or is this a real operating system? Okay, so there's some blah blah about zeros and ones and processors. So the generic introduction text always. You will need Microsoft Visual Studio. No, I'm definitely not going to use Visual Studio for creating my operating system. So that would be really funny if that's really required. So it's required to create an operating system to use Windows along with Microsoft Visual Studio. No, definitely not. Step 3, Introduction to Cosmos. What's Cosmos? User Development Kit Milestone 4. Any virtualization software to run the OS. I'm using VMware Player. Okay, so yeah, that's definitely a point. I need VMware. So let's check the software center. VMware. Or VirtualBox maybe. VirtualBox. Install. Only available as a system package, but fine, okay. I'm going to install VirtualBox because this way I can somehow create a disk image that contains my operating system that I can launch here. Let's see. Writing your first operating system. So first, let's write a OS, which can simply print some text on the screen. Oh, that's perfect. Open Visual Studio. No, I'm not going to do that. In the new project dialog, select Cosmos. No, I'm not going to do that. Now you see a file, program.cs, and the Solution Explorer. No. And here, this guy creates a file and edits the code under public static void init. I still don't see how this ties together into building a complete operating system. What's Cosmos Builder even? Is this some tool provided by Microsoft to create an operating system? But why would Microsoft do that? That does not make any sense. So I'm probably misunderstanding something. And yeah, no. This is all not what I want. How to create an OS from scratch. So what have we even learned so far? We have learned so far that we need C programming probably, assembly, maybe not. If we're crazy dudes, we can do it in C#, but then we're tied to the Microsoft environment. And it's probably, no, yeah. And aside from that, we need some virtualization software to be able to test our operating system. And not even that is working on my machine right now. So maybe let's pick some app image or something. So I need a virtualization software to be able to run my operating system. That's fine. I'm going to pick one for Linux distributions here. Ubuntu, which one am I using? I think 2404. And this is a Debian package. Okay, now that it's downloading, we should be good now. Requires 2 changes in other packages. Hopefully not my drivers. I'm just going to do it. Okay. And maybe the better question is how to create an OS image. No, but that's more for creating an image of an existing operating system instance that you have. But I want to create something that's just mine. How to write bootable code. How about that? How to write bootable code. Create a bootable program. Yeah, because that's just a step below writing a complete operating system. I think there are some bootable programs. I think Rufus. Is Rufus bootable? No, and it's not. No, that's not it. But there are some pieces of software that you can pull on a USB stick and then boot from that USB stick, and that's software that runs outside of an existing operating system. And I don't know how these things work. So these are bootable programs like this guy wants to know about. So here, this guy wants to program his own bootable USB stick. That means creating an ISO which he can burn to his USB stick via unet in boot. I know there are many lightweight Linux distros out there, but I just need to mount the HDD and do some basic file operations, copy, replace, and such. I want to display something on the computer screen. That's a good start. That's a really good start. So learning how to do something, and in our case, learning how to create an operating system, also involves learning to break down the task. And in my opinion, this is a perfect reduction of the task. We just need something. We just need a bootable piece of code. That's the difference between an operating system is in essence, or differs in essence from this code right now, by its bootability. So I wouldn't be able to boot this user space program in any way. So did this guy receive any answers? Grab a copy of a lightweight Linux distro and modify it to fit your needs. If you want to start from scratch, not recommended. Take a look at C and assembler. Why do you want to reinvent the wheel? There are plenty of live disks and live disk creators. Why do you need to program anything for that? Those allow you to just put in the functionality you need and nothing else. Arch Linux is super light and console only for the live CD. Yeah, but it's not really creating an operating system if we reuse Linux, or is it? It would also be an alternative to just pull in some Linux code, modify it to just display exactly what we want, and then create from it a virtual image somehow. I don't know how this can be done. 2, here's an answer. To just mount the HDD and do some basic file operations, you still need to be able to operate all the hardware on the machine. Okay, I see. And that's something that I probably won't want to deal with. So an operating system boots from nothing and then is already able to operate all the hardware on the machine. And all the hardware, if this statement here is correct, means all USB devices, the displays, monitors, mice, microphone, whatever is connected to the computer and you want operational. So you need an OS to some extent. You could certainly strip down what that OS contains to a great extent, but that's on the order of doing what the lightweight Linux distros have already done for you. You're almost certainly best off just using one of them. Okay, that's convincing. I didn't think of that. And when you run a Linux distro, the difference here, what makes the entire project simpler is that Linux already provides support for devices, and you don't have to worry about that. And that's something that you always forget. I often think of Linux as whatever I see on the screen. And then I think, okay, I want to be able to create my own terminal, so I don't need Linux because it's not graphical. But that's of course completely wrong because Linux is doing so much under the hood. Without Linux, I wouldn't be able to see anything on the screen first, but I wouldn't be able to control anything on the screen either, and I would not even be able to interact with the computer. So it might be worth looking at a lightweight Linux distro. So let's check that. Lightweight Linux distro. NTX, Bodhi, Puppy, and Sparky Linux. Or just Arch. But maybe the more important question for me is how to create. Well, first of all, I have 2 questions now. Where do I find the complete source code of a Linux distribution? And second, how do I compile it to a disk image? How to create a disk image from a Linux distribution. Create disk image of directory. How to make a disk image and restore from it later? No. Let's say I'm just going to use as a basic as a basis Arch Linux? Or is that already too much? Because I know that many people say that Arch is super stripped down. It's lightweight. That's fine. On the other hand, I don't know how lightweight it is compared to other lightweight Linux distributions. Let's have a look at Arch Linux and what do we find in the downloads directory. So it's a 1.4 gigabytes ISO already. That's quite large, isn't it? Considering that we just want to print something on the screen. If I search for another lightweight Linux distribution for, I don't know, for custom OS, Arch Linux is ideal for building a custom OS from scratch. Okay. Alpine Linux, of course, I've seen that one before, especially with Docker containers. Let's have a look at Alpine Linux. So this one here comes compiled for several architectures. But what's the size? That would be interesting to me to see. Let's check the download for x86-64. 347 megabytes only. Arch or Alpine for custom OS. Can someone please highlight the key difference between Arch and Alpine Linux? Here someone on Reddit is asking. So Alpine is smaller because it doesn't use glibc or systemd. Glibc, we don't need systemd, and neither do we need glibc because we are doing all the compilation outside of the operating system. Systemd is the system daemon, which is automatically booting things in your when you start your computer, and it's it's like an auto launcher as far as I remember and understand. And this guy responds, Alpine and Arch shares the same simplicity-focused approach, but Alpine even goes into it way deeper, allowing the whole distro to work fine in RAM disk. It's also totally fine to be on read-only drive. Arch is just your regular distro. There's nothing Scratch in it. It's okay, fine. So maybe the conservative approach here would be to download Arch, and then because it's stripped down enough, or Alpine Linux. I don't know. I wanted to say the conservative approach might be to download Arch and then try to modify it and create an image from it. But on the other hand, Alpine is also super nice probably, but I don't want to run into stupid package issues. But I think, no, let's go with Alpine since it's absolutely minimal. Okay, now that we have Alpine downloaded, this is an ISO of Alpine. Maybe we can have a look inside. You have just inserted a medium. Open folder. I want to open the folder. Let's see what's inside. It contains a boot directory, an APKs directory. Is that like an Android APK with apps installed? It looks like that's the case because there's OpenSSH here and some other things, YAML, wget, all the important stuff. And then there's an EFI section. What was the difference between boot and EFI? I already forgot. Boot, EFI, difference. So boot and EFI are directories. If you have a 500 megabit partition, this is about partitioning. This question is about the partitioning. The EFI partition is a FAT32 formatted partition required by UEFI firmware to boot the operating systems. containing EFI binaries. Conversely, boot is a directory holding kernel images and bootloader configuration files. Modern systems often mount the EFI partition at boot EFI. Okay, so EFI stores bootloaders. It's required for UEFI booting. And then the boot partition stores the Linux kernel. But what do I need to modify here to be able to boot my own stuff? Modify Alpine image. Let's have a look. How to make a custom ISO image. There are third-party scripts to rebuild completely custom images, like Alpine make VM image works to only make a disk-based VM image. And there is Alpine's original make image. It creates a diskless ISO file, usually what you want for QEMU and Proxmox. It's also possible to commit and load an ISO image customizations to and from a writable partition when booting in diskless mode. Okay, so this is a super minimal documentation. What is this Alpine make VM image about? Alpine make VM image here. This project provides a script for making a customized Alpine Linux disk image for x86-64, so in our case, virtual machines. You can choose between BIOS mode and UEFI mode. It's quite simple, 400 lines of code, fast, and requires minimum dependencies. You don't need a VM, just want to change root into Alpine Linux. Yeah, blah, blah, blah. Linux system with common user land. So how to create images for x86-64 hosts. All you need to do is install the QEMU user space emulator. On Alpine Linux, do this. On Debian Ubuntu, do that. Why do I need this? QEMU user space emulator and register it as the interpreter for Arch64 binaries. I don't understand what they are even about here. Again, my goal is just to have a disk image that boots, and I want to display some custom text. That would already be awesome. How to mod Alpine Linux. Build custom OS based on Alpine. Create based Alpine distro. Can anyone help me with how to create a basic distribution based on Alpine Linux? So here this guy wanted to create his own Alpine-based system for his server. He has used TISO for this. You have the ability to create an AI root file system or AI root FS, which then gets copied into the ISO. And then you just proceed to configure your ISO how you want it, like you would do with any other distro. Simply unpack mini root FS and change root to it. You have your basic Alpine Linux. Of course, you need a kernel to boot it. And then we are let to this page. How to make a custom ISO image with make image. This document explains how to build a custom ISO image using the new make image scripts located in A-ports. What's A-ports even? Is that something inside Alpine? But I want to wait. I'm currently using a different distribution. I'm using Linux Mint. So how can I use anything provided by Alpine in order to create an Alpine image, a modded Alpine image? Testing your ISO image. QEMU is useful for a quick test of your newly created ISO image. This ISO build process has been tested to work and generate an ISO with auto-installed APKs with Alpine Edge. I really feel completely underqualified for this project, guys. So for this to work, how to make a custom ISO image with make image? I first need to install stuff inside Alpine, and then I'm going to do what? I just want to execute some C code. So where is that happening? Somehow I feel like I'm led down the wrong path. Maybe here. Or maybe create OS image based on Linux. Let's just say that. Let's just search for that. Create an image file of a running Linux system. No, that's not it. Create OS image. No. Modify Alpine to run custom program on boot. Maybe like that. And of course, this is using Gemini now. But okay, let's see if it prints out something useful. To run a custom program on boot in Alpine Linux, place an executable script in etc local D with a start extension and ensure the local service is added to the boot run level using rc update add local. For persistent changes on diskless installations, run lbu commit to save the configuration. Script to run at boot. But I don't want to have a script run at boot. I want the boot itself to be just the script or just the program, whatever. I have a USB flash drive which boots Alpine Linux into RAM. I wish to run a script directly after startup. Log into Wi-Fi, etc. Is that possible? No, I don't want that. That's already way too late. Run a script after booting Alpine. How to modify boot of Linux ISO. Modifying a Linux ISO boot process involves extracting the ISO contents, editing configuration files, replacing necessary files, and rebuilding the image to be bootable using X or XOR ISO or make ISO FS. Essential tools include Gen ISO image. Wait just a second. Gen ISO image. So this right here is, I should put it in a different directory. Let's just give me a second here. Documents, let's get a directory here for my own, or no. I'm just going to do it like this here. Projects, operating system. I'm going to move from downloads the Alpine here. So now in my custom operating system directory, I have the Alpine ISO. Now we can work with it. So extract the ISO contents. Let's just stupidly follow this. Linux extract ISO to folder. You can do this using 7-zip. Okay. ISO info to extract all files, or this. I know that I can just right click the ISO and then extract it. Or I can use 7-zip, Linux, or Ubuntu 24.04, 7-zip. Is it already installed? Oh, nice. So 7-zip x 7z x Alpine. Now, oh, okay, now it has extracted everything to the current directory. Is that what I wanted? It's fine. Now we have a directory filled with operating system files. Now what do we do with it? We edit configuration files. Let's just have a look here. Let's search for group. No, there's nothing. Maybe let's search for all conf. I was rip grabbing. That's of course wrong. Let's find group. There's the group configuration. That's the bootloader as far as I know. If I open it in Vim, let's see what's inside. Okay, so this is the bootloader configuration as far as I know. Let's see. It boots a Linux long-term support version. This is the line booting Linux, it seems. It accesses VM Linux LTS modules and all of these things. No idea how that's supposed to work. Let's have a look at ISO Linux. Using find ISO Linux, there is a binary file called ISO Linux binary. That's not what I wanted. Steps to modify a Linux ISO. We extract the ISO and copy its contents to a working directory to allow editing. We modify the boot files, navigate to the boot directory within your extracted folder and edit the configuration files to change kernel parameters or menu entries. Rebuild the ISO. Recreate the ISO file using XOR ISO or make ISO FS, ensuring you maintain bootable parameters. Make it bootable. Okay. The common answer is to unpack the ISO file, modify it, and pack it again. It looks like ISO master is a good front end to do that. Okay. In summary, we will replace an existing file in the ISO FS file system with our desired file. Our desired file must be smaller than the existing target file, and trailing whitespace must be acceptable. This actually requires only 2 commands. Why is that necessary? I don't know. Do we need to still match the file size? In my case, I wanted to store a script in a live boot so that I don't have to retype it every time. The script is at script.py and my target is at devs SDC. The size of the script is that. Repack ISOs with its original boot equipment. What's that about? Make customized Alpine Linux root FS. Well, but maybe it would make sense to try to understand this group configuration here. So let's look at group.cfg example. Or not example, but maybe some documentation in general. Syntax is maybe even better. Here, GNU group. This is the documentation of GNU group, the Grand Unified Bootloader. Okay. So what do we do? The role of a bootloader. The following is a quotation from Gordon Matzigkeit, a group phonetic. I'm going to skip a group phonetics quote. I just want to find out how to put a program in there and boot it. It can't be that hard, guys. Making a group bootable CD-ROM. Installing group using group install. What do we actually need from here? How to boot operating systems. How to boot an OS directly with group. Or wait, how to boot a program with group. How to boot from group shell. Booting with group. Multi-boot is the native format supported by group. For the sake of convenience, there's also support for Linux, blah, blah, blah. If you want to boot other operating systems, you will have to chain load them. Multi-boot is if you want to be able to select different things you can boot from. So this configures the menu entry Linux LTS, which is a single entry in the group bootloader. Maybe. What is a module in group? Squash FS, fmod, quiet, init ram fs, LTS. group modules list. What is that? Modules. In this chapter, we list all modules that are available in group. Modules can be loaded via the insmod command. Those are kernel modules that we want to load. Wait. And in one of the last episodes, we have created a kernel module ourselves. So maybe we could use this to load our own kernel module on system boot. Okay, I understand. But then probably we don't need to do any changes here. What? Let's just scan through the files and find if there's anything in here that is worth manipulating. So here I execute the find command, fd find, and it finds all the files in the current directory. It finds APK files, which are application files. Then it finds, let's see what else it finds. This is the group configuration we just had opened. And these right here they were referenced in the group configuration, if I'm not mistaken. Let's just check. No. The initram fs lts is referenced from there. And this might be a compiled kernel module, which is now here. Can we even check this using mod info? Let's check it. This is a package, or it's a program that gives us information about kernel modules. Okay, no, this is not a module that's somehow understood by my Linux distribution, I think. No idea. What else is there? There is ISO Linux bin. Syslinux config. What is that? Syslinux config. Okay, this looks like configuration that... But what does it do? It lists some menu, labels. No. I don't know what this is for. So let's see what else we can find in here. Let's do another find and see. So how do I know which of these applications is executed? Well, probably the simple answer is no, none of these applications is executed by default because Alpine is so stripped down. But then I don't understand exactly how what the boot order here is. What is the boot order in Alpine Linux? What is boot.cat? And this is just a binary file. It's just data. Okay. ISO Linux bin mboot. So how to create a bootable program. See, this is a tutorial for a very basic bootloader. It doesn't have much to do with C, but it has some really good information on the basic building blocks of a bootloader. I don't want to build a bootloader. I just want to have a bootloader boot my own program. A bootloader must be 512 bytes long. That's fun. It must end with the bootloader signature 55AA. And the bootloader, it seems, is just pure assembly. So maybe that's what we needed assembly for. Never-ending boot loop, loop boot sector. Main, jumps to the start of the instruction, never-ending loop. So this enters main, jumps back up, down, etc. Character on the screen, bootloader. You want to build a statically linked binary, and you start it by jumping to its entry point. The entry point is usually the start of the text section. How to make a bootable program? Is it possible to make the CPU run just this code right here? Yeah. Why is it so hard to find out about this? I don't understand it. What makes it so difficult? Why is there nobody on the internet saying, yeah, do exactly this and this and that, and then it works? I'm searching for 56 minutes already. This is a topic of a whole book. Why? It's this OS Dev website. Seems like a real, tough, very basic question to me. Not tough, though very basic question to me. In the case of your program, it does not rely on any operating system services other than getting it started. If it were to additionally do input or output, it would almost certainly rely on the operating system to perform the I/O. Okay, fine. If you want to replace the operating system with your own code, then you could well do it. Minimalistic operating systems and program loaders exist, but yes, you have a lot to learn. Printf is about the worst C library call to use. It reaches in so many directions. Floating point, string stuff, division. Avoid it for this kind of thing. I see that you have not but read the comments. What? Why is this question so hard to answer? Here someone wrote a program that is a bootloader, and this is the bootloader right here. Okay. And he writes it in different forms of assembly, then assembles it. That's essentially converting it to binary, and creates a floppy disk image. Why the hell would I need a floppy disk image? Create a 1.44 megabyte floppy disk image and write the bootloader to it. And creates a bootable ISO and then tests the ISO. Okay. But I mean, where's VirtualBox? Let me just open VirtualBox here. So didn't I just install it? VirtualBox? Here. Package installer. I failed to download the packages. Is this maybe because I'm using Proton VPN right now? Let's disconnect here. Close. VirtualBox. Where's the installer? There it is. Here. Dependency is not satisfiable. What about the other one I downloaded? Here. Install package. Let's do this. How to create a program that group boots. How about that? Creating a program that group boots. I hope it installs here in the meantime. Creating a program that group boots involves creating a bootable image and adding a custom menu entry to the group configuration. Adding custom entry to group. This is the safest method for permanent additions to your group menu. So this... What about this? Menu entry my custom program for a Linux kernel. Set root Linux image custom for a chain loader. What is a chain loader? Update group to apply changes. Create a custom configuration file. Why is it so hard? I really expected that I can just write some program, add it somewhere into an ISO, and then have the ISO run just that program. It cannot be that hard, guys, really. Creating a program that group boots involves creating a bootable image and adding a custom menu entry to group configuration. By the way, if this VirtualBox thing does not work, I'm just going to install another. It did work. Okay. So there it is, VirtualBox. Now let's just test it with, how did it work here? Open projects, and then there's the operating system. No, and this is for opening a virtual machine file. Of course, I want to open an ISO. So here, this is vanilla Alpine. Let's see how that one works out. This is my VM folder. The ISO sits in my projects directory, operating system here. This is an OS based on Linux. Oracle Linux, no. Arch Linux, no. What is it even based on? I don't know. Other Linux. Okay. Base memory 512 megabytes. Let's make it 1 gigabyte approximately. Let's give it one CPU only, and then next, finish, and start. So this is now the vanilla Alpine image distribution running here. As you can see, there is some stuff running. Okay. OpenRC is starting up Linux 6.18. This is the kernel version, long-time support. It's mounting things. And then that's already it. Localhost login. What can I type here? It's probably root. Yeah. Okay. Now I'm logged in as, am I logged in as root now? What can I do now here? Where's my mouse? Oh god, now my mouse is trapped. Oh. I just pressed Alt and F4 and this happened. So root ls-l It's an English keyboard, of course. ls-lh. Okay, is there vim? No, of course not. There's cat. Is there less? Yes. Okay, so there's some stuff here. How can I even escape the capture here? I need to somehow escape the capturing. I need to look it up online. So, what's that called? VirtualBox escape. VirtualBox. I'm looking up on my phone, by the way. Escape mouse capture. How to release the mouse from VirtualBox. So what we do is, of course, there's the host key that VirtualBox reserves. By default, it's the right control key on your keyboard. Okay, I pressed it, and now I have my mouse again. So now I can probably close this. We've seen the normal Alpine Linux in action. However, now what? Now, so something we probably need to be able to change something in the boot directory here. ls-lh. There's group inside. And group loads the the Alpine operating system. Vim group configuration, and it loads all of these things here, which are kernel modules. Okay, and then I want to damn it. Is there even bash under here, or sh? Bin shell. Busybox bin shell. That's maybe the shell. Let's just scan through all the files. I need to somehow hack this. So maybe it would be a solution to modify the shell binary somehow to, instead of running the shell, print whatever we want to print. But how do we do it? APK. Can we unzip an APK? Let's just go into I'm going to check this again. So vanilla Alpine. Maybe what shell does Alpine use? Alpine uses Busybox Ash shell for its default shell. It's a standard POSIX shell derived from Debian Ash. Okay, and now here inside Alpine Linux, why can't I even zoom here? No, okay, it's fine. Maybe it's possible to zoom in under view, scaled mode. Where did it go? No, I don't want it small. Let's remove all of those. No. How can I escape scaled mode? Oh God. I'm going to make this, guys. You will see. Everybody ridiculing me now is going to see in the end we will succeed. Boot. Wait. Escape. Close this. Power off. Settings. Display. Remote display recording. No. Basic. VirtualBox scaled mode, exit, host key and C. Okay. Fine. What about full screen mode? How does this one look? That one looks okay-ish. It's quite small for you probably, but yeah. Maybe if I do something like VirtualBox or Alpine Linux Zoom. Is that even implemented in Alpine? Zoom terminal. Probably it's implemented, but because I'm not using an English keyboard, it's not working. But I think I know which key is A plus in an English keyboard. Or no, I don't. Okay. Anyways, so what's going on here is, wait, there's a start message here. Welcome to Alpine. It's right there. Welcome to Alpine, kernel blah blah blah. The Alpine wiki contains a large amount of how-to guides and general information about administering Alpine systems. This is a start message, and maybe if we are able to modify this message, then that's already a small success. So if I search for the Alpine wiki contains, let's see. Rip grab the Alpine wiki contains. Or grep -rl to be able to also search binary files. No, why is nothing found here? The Alpine wiki. My stupid neighbor just turned up his music all the way up. I hope you don't hear it in the recording. We have an alcoholic neighbor. Every day he turns up his music all the way, drinks beer until he's drunk, and then yes, it's just ridiculous. I'm always shocked by how people can be. There are a couple of houses around, and everybody's silent all day, and this guy is just partying in his garden in the middle of the entire circle of houses around his garden, and he's disturbing everybody. It's ridiculous. Okay, but anyways, it has nothing to do with the video. I just want to find this message here. Grep -rl the Alpine wiki. Why is nothing found? Maybe instead it would make sense to find out how the default shell is even launched. How is the default shell launched? That is a good question. How is default shell launched in Alpine? Which is launched as bin shell. It is a lightweight POSIX compliant shell that starts instantly upon user login or container startup. It is configured via etc profile and .profile and uses the env variable to source initialization like .ashrc. Wait, what? if I cd into the root directory and then use grep -rl to search for the welcome to Alpine message. What if I just search for welcome here? Does it find anything? No, it doesn't. What if I go into home again? List all the files. Why is there nothing in here? So maybe we can just switch out the shell somehow. So the default shell is bin shell like this, and it's a symlink to bin busybox. And this means if we find busybox here, there it is. If we replace this file with our own program, then maybe we're able to run something. But how does this file even work? If I check it, this is an APK file. It's gzip compressed data. So we can unpack it or what? Let's go into here. Or let's copy this file here. And then gzip. Can I do tar xf busybox? No. It's gzip compressed. Compressed does not mean that it's multiple files. Or does it mean that, wait, if I move busybox like this and rename it to tar gzip, then maybe I can reuse tar to unpack it. No. But how can I maybe I can just create my own APK file for Alpine. I can compile it and then somehow etch it into the operating system. So Alpine compile program. Compile software from source here. Or wait, how do I compile a C program for Alpine? APK add GCC muscle dev. So maybe I have to compile it inside Alpine. How do I cross-compile it? Wait, statically against. Alpine distribution uses Musl as the standard C library implementation. Ubuntu distribution uses glibc. They are incompatible with themselves. By incompatible, I mean that a binary compiled under Alpine is linked against the Musl library, not against glibc. There are two solutions. You can install Musl library in Ubuntu so that the binary can link against it, or you can install glibc in Alpine and compile the binary in Alpine while linking it against glibc, or you can compile your binary statically against Musl. You can install. So, does this even have nano? No, it doesn't even have nano as either. So how the hell do I do anything in Alpine? Musl link against Musl in Ubuntu. Let's have a look. or Ubuntu link or Ubuntu Musel package. Sudo apt install Musel tools. So maybe if I move everything that I don't need here, or let's just remove everything. APKs bin boot, then the capitalized boot thing, EFI. Okay, now let's create a directory called ISO, and the ISO lives inside this ISO subdirectory here. And then inside our source file, vimos.c, this is what we're doing here. So we're starting the operating system, starting Daniel's custom OS. And now I want to compile my file, my source file, which is os.c, against this Musel library that Alpine Linux uses. How can we do that? We do this, we sudo apt get install Musel tools. Then we install them. And now how can I use them for building Musel GCC? Use this to get Musel GCC, which wraps GCC and sets correct include paths. So now I can statically compile a binary like this, Musel GCC static. Let's call it OS, and the source file is os.c. This worked. Now I have a file called OS. If I check it, that's recognized as an ELF file. I can probably not execute it on my current OS. Oh, I can. Interesting. Why can I use this even? Maybe because it's statically linked. And if it's statically linked, then it contains all the dependencies. And now this is my binary. And what happens if I do, if I go into the ISO directory, 7-zip, unpack everything in the ISO, then I find my APK, and how do I, and I thought maybe the naive approach would be to just go in here, find some APK, for example, the shell. Where is it even? There should be a shell in here. Here in BusyBox bin shell, and replace it with my custom one. What happens if I execute the BusyBox bin shell thing? Change mod +x BusyBox bin shell, and then I execute this. Okay, this has a format error. This is fine. Let's remove this again. But maybe it's even better to find out what the difference is between a regular binary here and an APK file. Create APK for Alpine. Creating an Alpine pack. Those are Alpine packages. Create APK for Alpine from binary. So these are packages, and probably inside the packages are are binaries that are somehow packed up. Yeah, Exactly. So this is just more complication here. Then instead of using the APKs, maybe there's something else. Is there, for example, the etc folder? No, there's not. Damn it. And probably everything is unpacked at installation or at some point. Where's the binary folder? Does it even exist? I don't even see a file system. Create APK package from existing files. The usual way to create an APK file is to use a build. However, I need to create an APK from a directory with files. That is without an aports recipe. That can be done this way. The problem with this is that it's way too slow. I want to speed this up. Okay, that's not my problem. Unless you really need maximum compression, try dropping it. You can use gzip instead of gzip. You can use pigs instead of gzip to utilize multiple cores during compression. No. How to turn binary into APK for Alpine. I don't get it. I just want to, well, currently the idea that I'm trying to figure out is maybe it's possible to replace the shell with just the binary that I'm executing, that I want to execute. But on the other hand, maybe that's also stupid to do. How about we just, I don't know, something must auto start in this damn operating system. But what is it? Something must auto start. Well, definitely the shell will auto start. It's all extracted from this APKs directory here, it seems. And then initram fs, I don't know, syslinux config. Let's have another look at this one. I know it wasn't promising. Kernel init rd fdt directory. Run program at startup Alpine. How about that? To run a program at startup in Alpine Linux, create an executable in etc locald with a start extension. Then enable the local service using rc update at local default. What? But how? Okay, assuming that's the way to do it. How to modify file system in Linux ISO? Because in the Linux ISO there is no such thing as the etc directory. It seems to magically just appear from somewhere. I ISO master. Yeah, we're back at this again. I already opened this page in the past. How do I replace editing an ISO file in Linux? Modify Linux ISO image. How to modify, maybe modify Linux file system inside ISO. Where does the file system in Linux even come from if it's not part of the ISO? I don't get it. CD boot, syslinux maybe, and then that's it. There's nothing in here. So maybe the file system is part of these binary files here. This is isolinux.bin. What is isolinux.bin even? isolinux.bin is a critical bootloader file used for booting Linux distributions from USB drives, typically used in ISO Linux for BIOS-based systems. What's inside Linux ISO? No, isolinux.bin. Boot code. Contains boot code. The file contains the executable code that acts as the entry point for the computer's BIOS, enabling it to recognize and boot the media. Initial bootloader, configuration link. Anatomy of a bootable ISO. That's an interesting link, interesting title. But way too complicated for me. ISO Linux bin is the bootloader file. boot.cat libcom libutil mboot syslinux.config. I already opened the syslinux config, right? Let's just open it yet another time, and there's nothing in here that I can get clever from. How to make Linux ISO boot custom program. How about this? How can I build a bootable ISO with my specific customizations? No idea. How to create a bootable USB from an ISO file. Compiling Linux and creating an ISO from it. Creating your own custom Linux ISO for a tailored. No. How to run custom program from Alpine ISO. Come on. Maybe the simplest way is indeed to modify the Alpine APK file. Here this guy was able to create his own APK somehow. But this is, I don't get why it needs to be so complex. Another way to add packages in Alpine Linux ISO. No login, just run a custom script once booted. How to make a custom ISO image with make image. This is the wiki that covers how to make a custom ISO, but it assumes you're building it on Alpine. First, make sure we have these needed tools, all of those. For EFI, you should add the following. Then create signing keys. Git clone. Okay. Make sure your temp is large enough. Then do some wizardry here. Making packages available on boot. A package may be available in the live system by defining the generation of blah blah blah. If you want to make a customized installer, do something else. Oh. Or what if I log into the Alpine Linux ISO, into the virtual machine here, I create my own binary in here, and then I replace the shell with that binary, and then somehow persist that ISO. That would be crazy. That would be really crazy. But there's no Vim here. APK add Vim. No such package. How do I even add Vim in ISO? How do I do anything? I have a binary. I want it to be executed at startup. Can I see the file system here somewhere maybe? Maybe it's possible to access this virtual machine's file system somewhere. So let's go here. Let's make this a bit smaller. Then settings, and then see where the file system resides. It's in this VDI file. Location of the ISO is here. Location of the VDI file is there. But I actually only want to modify the ISO. custom Alpine ISO builder. You need and install Alpine system on a disk drive with enough disk space. This system is Alpine master. Copy 3 files from the builder directory into here. From builder directory to this. Build ISO in root. What? Gemini. Do I need Gemini? I mean, what am I supposed to do now? How does the kernel know to start a shell? All ridiculous. Find.name. No. Find everything. This is all compiled files, packaged files. I can't really modify anything here. VM-LTS. How to mod Alpine Linux. Modifying Alpine Linux involves customizing its minimal base by installing packages via APK to persist changes in diskless mode or editing APK repositories to use edge testing repositories. To create a custom bootable ISO, you can use make image scripts or use setup Alpine to configure a customized lightweight installation. Make image. I've seen that a couple of times today already. Make image Alpine. Maybe Alpine set keyboard language. That's actually a stupid problem that I'm facing right now. So here, set up key map. Okay, let's go into Alpine and set my keyboard layout. This is the stupidest problem I'm facing today. What do I need to type? I already forgot. Set up key map. What? I just want regular German here. Okay. Now, how can I install Vim? That's the next question. Alpine install Vim. APK add no cache Vim. Okay. APK add no cache Vim. Vim no such package. Maybe I need to APK update first. Capture APK update Vim. No. APK update. 102 distinct packages available. APK add Vim. Vim no such package. Alpine Vim no such package. You need to add community repos. Vim to this, then uncomment the community repo, the one that has community by the end. What? Vim to etc APK repositories, but I can't use Vim without... Wait, I need to edit some file with Vim, but of course there's no Vim. So how the hell am I supposed to edit this file? Am I even connected to some network? Network settings. Attached to net. Bridged adapter maybe? Okay. Package missing in Alpine Linux, even though it's listed on package repo website. Which text editor is installed in Alpine Linux? VI. Oh, VI is there. It has VI. Ah, of course. And that's already the same thing as Vim, essentially. So, okay. Okay, we can use VI. It does not work exactly like Vim, but maybe that's good enough. Okay. Can I zoom in now? No, I can't. Okay, that's already good enough. So now I have Alpine Linux, I have a German keyboard set up, and I can use VI. If I now check if we have GCC, no, that doesn't work. Sudo, no sudo, apk add. Now I want to compile a program on Alpine directly rather than outside of Alpine on my host machine. So how about I look for Alpine compile C program. How does it work? apk add gcc and musl dev. Okay, apk add gcc and musl dash dev. But they are both not available. So probably I first need to edit at C something here. There was some repository. How can I add repositories in Alpine? And that was exactly the issue that I was talking about in the beginning. I don't want to pick a distro that is too stripped down, because then doing every little step is adding friction. Because I'm going to face unnecessary problems like this one. So Alpine apk update not working. Or maybe I need to confirm that I have internet at first. Alpine, check if internet connection. Ping, we can just ping something, of course. Or IPA. I have an Ethernet adapter. What if I ping www.google.com? This does not work. Bad address. Well, what can I ping then? Google.com. So maybe the issue is that I don't even have internet on my machine. So let's try and see. network, connect network adapter. It actually is connected. Now it's not connected anymore. Wait, I select NAT, attach to NAT, enable network adapter, input, devices, network, connect network adapter. This does not work. So, VirtualBox, Alpine, no, Internet. Select network, attach to NAT, go to advanced, adapter type. Go to advanced. There's advanced there as well. Virtual cable connected is ticked, but there's no advanced here. Maybe he means this expert mode here. I had to add a lot of configuration in my system, then it worked for me. Alpine Linux configure internet. Setup interfaces. Let's just type this. Setup interfaces. Available interfaces are ETH0. This is the one that I want to use. Yes, yes, yes. And maybe now I have internet. No. This is really the trashiest episode ever. Google IP 888. Let's try to ping this one. 142.251. 142.251. 32110. 32110. Network unreachable. Okay, guys, I have decided. Let's keep it. Let's keep it real. My patience has completely reached its limit. I've asked ChatGPT. So I asked, I have an Alpine Linux distribution ISO. How can I change it so that it boots to my own program? This is the program I want to boot, and then I just pass it my program. So what you're asking is, how do I remaster a bootable Linux ISO so it launches my own user space program immediately after boot? Your C program is not an operating system. That's fine. So easiest would be on Linux PID, so process one is the first user space process as been init normally. If you replace it, your program becomes the first thing the kernel runs. So I can compile it statically, Daniel OS. I have already compiled it on my machine here earlier with you guys. So there it is. And static linking matters because early boot may not have all shared libraries available. Okay, fine. Okay, then we extract the Alpine ISO. We have already done this. And then we unpack init_rum_fs, and this point I didn't know. So the init_rum_fs binary, let's just search for it, init_rum_fs, seems to have something to do with the file system, of course. But how does it work? So this guy, what I wanted to say, this guy says, well, ChatGPT says I need to unpack this file, and then in this file replace some init file. So there's some initializing process inside this init_rum_fs. So let's try to do that. I'm going to unpack init_rum_fs. And what? Wait. Make directory init_rum_fs and cd into it. Let's do that. So now I'm inside init_rum_fs, and then I go up. No, I gzip-dc, gzip-dc from the ISO boot init_rum. It should be in here. It's not. ISO boot init_rum_fs. Init_rum_fs. Maybe it's just not auto-completing. -lts. This is then piped into CPIO. What does CPIO do? Copy in, copy out is a powerful command line archive utility for Unix-like systems. Created in 1977, it creates, extracts, or lists files from archives by processing lists of file names, usually piped from find or ls. IDMV. Let's just do it. I have absolutely no patience anymore. IDMV. Okay, so this has now done something. And this is where the entire file system resides, guys. As you can see, what we are now seeing here is a full Linux file system. Or no, it's not. It's actually the user libraries, it seems. And the var directory. Let's have a look. No, it's the complete file system. I've extracted it all into here. Okay. So this is now the complete file system of the Alpine Linux ISO. Then we replace init, backup original. We back up the original, move init. There's the init file. So let's move that and call it alpine.init, like the guide suggests. This is the initializing file. By the way, is there such a file on my machine? This is now my local operating system. No, maybe it's bin, but I don't know. Okay, interesting. And now we can replace this init file with our own binary. But later this guide states that we have to fix the operating system implementation or custom code to use a while true loop here. Otherwise it will exit and then the operating system will just appear to have crashed. So we need to keep alive the operating system. Let's do that. While one sleep one semicolon, don't forget the semicolon, and then import unistandard, which provides the sleep implementation. And then again, I need to compile my source file. Let's see, I compile it statically like this. Daniel OS, okay. Here, remove the OS I created. Let's do this. Let's create it statically. Source file is called os.c. So now I have my Daniel OS file. Let's also remove the a.out. And let's move Daniel OS into init_rumfs and then probably init, because that's the default name for the init file, which is the first executable that is actually being executed. Here, yeah. Okay, so let's copy. Ah, damn it. Let's copy this file into init_rumfs. Init, change it to this directory, make sure it has executable permissions, but it already has them, but okay. And now we can repack init_rumfs. So we grab all the files, we somehow use the CPIO thing again, and then gzip everything again. Oh, this is a horrible pipe, but okay. So let's copy paste. Find dot, finds all the files, somehow does something, then gzips them all and puts them back to the ISO directory in my case. And okay, now we have created a new init_rumfs in the ISO. Boot, let's check here, init_rumfs, there it is. And what is the next step? Rebuild the ISO using XOR ISO. What is that even? XOR ISO. It's a command line tool that creates, loads, manipulates, and writes ISO 9660 file system images with rock-rich extensions. Okay. Is that already installed? XOR ISO. No, but I can install it using this command. Let's do that. Okay, and now let's get that command here. So we are using this XOR ISO thing with a make ISO file system command, probably. This is the output files. This is the output file. This is the boot file, I think, whatever this cat file is. So, okay, I admit, if I have learned one thing, and the episode is not even over yet. If I have learned one thing in this episode, then it's that operating system stuff is horrible. What is the next step here? XOR ISO failure cannot determine attributes. I'm in the wrong directory, of course. I need to call it from here, from the parent, where I can reference the ISO directory. So let's again paste this command and replace work with ISO, because that's where my ISO resides, at least where the unpacked files reside. Okay, it has written to Daniel Alpine ISO successfully. Now I have a Daniel Alpine ISO file, which is ridiculous. Somehow it has twice the size of the original ISO from Alpine. Why is that? Because it, of course, also contains the original ISO, which is also packed together in the new ISO. So let's remove that, create a new ISO by recalling the XOR ISO command. Let's try. And now it should be roughly 300 something megabytes. Okay, now it's approximately the same size as the original. That's now correct. And now we can boot it. What is this QEMU thing? I wanted to boot it in this VirtualBox thing, but what is QEMU? Maybe because we've read it, or I've read it so much today, maybe it's worth taking a look at it now. QEMU is a generic and open source machine emulator and visualizer. Running the React OS. Maybe that's just an opportunity to have a look at it. Let's just check images. Yeah, okay. Looks very similar to the VirtualBox thing that I'm using. Is it even installed? If it's installed, then I'm going to try it. It's not installed, but I'm curious. Let's just install it while we're at it. And then I can mount the ISO using the -cd-rom flag. Okay, let's do that and see how this looks like. And now it's printing that it's booting. Can I zoom in here? No, I can't. Okay, I get a kernel panic. System is deadlocked on memory. Oh. I hear my CPU spinning up already. Something is wrong. Something is seriously wrong now. Press Ctrl-Alt-G. Ctrl-Alt-G to release the tab. I close it. Okay, so something didn't work. What didn't work here? Why did it print system is deadlocked on memory? What happens if I import the same ISO in the VirtualBox? So let's create a new virtual machine here. Call it Daniel's Alpine and select an ISO from my own directory here. And then do OS, Linux, finish, and boot. This one's working, guys. Oh. This one's working, guys. This is a working ISO. As you can see, it's starting just one single thing here. Let me just open scaled mode so you can see it. This is great. It's working. It's printing, starting Daniel's custom OS, and that's all it's doing. As you can see, this is now like a bootable medium that you can plug into any computer, and it's really booting, starting Daniel's custom OS, which is what we have, which is exactly the thing that we have created. So now we know how to, on a fundamental level, how to create programs, put them on top of a Linux ISO, and just boot them right away. This is crazy, guys. I'm actually surprised that it worked in the end. So now, of course, I can't do anything because my program isn't doing anything, but that's the entire point. I have loaded my own program here. And this is the core of this. This was actually my goal in this episode. I now have my own modified operating system that starts my own program right away. And of course, I could now start any program that does whatever with the user. And oh my God, this is crazy. So yes, I know it was a very long odyssey. It took forever. It was a huge, it wasn't a waste of time in the end, but I wasted a lot of time that could have been saved in this episode by going down so many wrong rabbit holes. But in the end, thanks to me looking up using AI how I can finally make it work, I made it work, and that's the main thing. So we learned something. We learned how to modify ISO files, how to override the initializer program. We learned some basics about bootloaders, about operating systems, about the file structures there. So even though this was an incredibly unproductive episode, we somehow achieved the goal. right? As you can see, starting Daniel's custom OS. This is exactly what I wanted it to print at the beginning of this episode. That's so awesome. And it's all derived from this C code here that we have created, which we launch as our custom operating systems initializer program. That's so freaking awesome. If you want to learn C programming from scratch, from ground up, again, have a look at the No Nonsense C programming course. It's linked in the description under the video. I highly recommend it. It enables you to understand computers quite well and enables you to write useful programs that you can do stuff with. It skips all the boring theory and enables you to work with libraries and get some useful stuff working. As you can see on my channel, similar projects we're doing also in the No Nonsense C programming course. Highly recommend it. Have a look, check it out. And aside from that, I hope you all enjoyed this episode. It was horribly enduring for me, and I need a break now. So see you next time. Bye bye.